Hi, and welcome to the second installment of the Profitap Talks. This is a recurring series of discussions with Mike Pennacchi about various features and topics regarding network analysis and packet analysis. My name is Roland Knall. Excited to have a chat with Mike Pennacchi about network integration today, aggregation today. Mike's been in the trenches of network visibility for years, and he's got some great insights to share about how organizations are tackling aggregation challenges. Mike, thanks for being here. Before we dive in, why don't you tell us a bit about your background and what got you interested in network visibility?
Well, what got me interested in network visibility was I was a network administrator for a company here in the Seattle area. And just to give you an idea of how long ago that was, we were using Banyan Vines and Bay Networks routers. And every single morning, about 9 a.m., our core router would reboot. And so I was tasked with the job of figuring out what was causing that. So I grabbed my Dolch with the network general sniffer on it and started capturing packets. And we found out that it was a broadcast packet that was going out. And now back in that time, we could get away with doing things like resending the broadcast packet to see if that was really it. And when we resent it, it took the whole network down. So we knew that that was the packet. But, that's what got me hooked. And once I started capturing packets and looking at those, there was no going back.
I think you just mentioned every network administrator screamed there, hey, what if I could only take the network down once by accident, and everybody's happy about it.
Well, we certainly did.
Yeah, but this topic of the day today is network aggregation, and we want to talk about it a little bit. Coming from obviously one of the more, I wouldn't say less complex, but less simpler times back then, you and me both. Today we're seeing networks of all sizes these days, right? So from your experience, how have you seen aggregation needs change over the years?
Oh, I mean, when you think about how we started out in the beginning with, a pretty simple setup in that we could put a hub. And I used to have a whole pile of hubs around. We could put a hub in line and we could capture all the traffic going in and out of the network. And that was easy. We could see everything. And certainly over the years, things have gotten faster, redundancy, just sheer complexity within the network, multiple paths, that it's made it much more difficult to bring all that data together into one place to be able to analyze it.
So we're more or less on a point that the hub was a one-size-fits-all solution, right? It was an easy enough thing. Some would call it was a dumb thing, but at the same time, it was nice enough. Can you share a little bit about common pain points that keep coming up due to the fact that the networks get complexer regardless of the size? What are the issues you see on your daily life?
Well, I mean, there's certainly this expectation that if you have a group that has bought network analysis tools or, even has Wireshark, that when a problem occurs, they're going to be able to go in and fix it. And so one of the challenges is getting that visibility in the right place and that, where do we monitor? How do we monitor? How do we get the right data? Oftentimes there's way too much data. And in fact, I would say that probably more than anything, that is one of the biggest challenges. And whenever we work with someone with Wireshark, teaching them how to use it initially, it's how do we eliminate everything that isn't part of the problem? And when you start out, you don't know what to eliminate, but we need to get rid of all the stuff that's working well so that we can focus in on just that traffic that we're most interested in.
So it's a little bit like putting a magnifying glass to the issue without really, by cutting away everything that works to get to the point where you want to be at. We want to structure this talk today a little bit in going forward and giving you your listeners the kind of a guide through of how network aggregation can be applied to a network and how it can apply to your situation. And we're going to start with this screen here about a small network application where you have your typical, I would say, small office, back office situation, maybe kind of an outer bound office, not the big headquarter. But at the same time, what would you say when we start out with the small scale situation here? What would you say is the most aggressive, or where are the points where you would say, this is where I need to talk about aggregation, this is where I need to talk about attacking my visibility first?
Well, certainly, excuse me, certainly between, our router and firewall, right? I mean, if you look at this diagram right here, for me, one of the first places that I would end up connecting in is, at that point, because that's going to give me that traffic going out to the internet. Now, there are times where I might want to monitor on both sides of that firewall to make sure that my firewall rules are doing what they're supposed to do and that I'm not blocking traffic that shouldn't be blocked, etc. From there, it's, what's going on with my servers and taking a look at, what traffic is going to and from those application servers. And another point that, it starts adding up to almost everywhere on here, but is to and from my wireless access points. Because what we find with wireless is it's very difficult to monitor wireless because it's really location specific. And so by being able to monitor there at that where our wired is connected to the wireless gives us that insight into what's happening with our wireless network without having to actually capture wireless packets. But the challenge becomes if I don't see traffic, let's say, making it out to the internet, where did it get lost? And that's where when I'm monitoring in multiple locations like that, being able to pull that together into one place so that I can see that the packet came in from the wireless network but never made it out to the internet, as an example.
One could argue, especially with a smaller setup, that there is no need to think about advanced network visibility because, it's just a bunch of servers, a few PCs. What the heck do I need to think about that? What would you say? What's your take on that?
Well, I mean, we have to have advanced network visibility because at some point you're going to have a problem. And when you do have a problem, how are you going to fix it? And I'll tell you what, they will always blame the network. When you have a problem and you call the person that's in charge of that owns the application, when you talk to the server, the people running the servers, they're always going to come back and tell you it's your network. And so if nothing else, just from the standpoint of being able to come in and say that here's where the problem is, and it's not the network or it is the network, we need to be able to do that. And we can't do that without some sort of advanced network visibility.
I'm a little bit going back to a talk last week because especially for the smaller setup, it just plays out. A second counter argument to say, okay, let's put tabs in there, let's put aggregation, data aggregation in there would be, I have all those switches. Why don't I do, 3, 4, 5 spam ports and just connect to those? Even in a small setup, why is this a problem?
Well, as we talked about, the problem is we may not see all the packets, the timing may be off, the switch may only support spanning in one direction. There's a whole slew of problems that go along with spanning. Now, I will say, I know we beat up on span pretty hard in the last talk, but I'll tell you what, if I was getting started with this, aggregating a number of span ports is not the worst direction in the world either. I mean, if I had to go about this incrementally, that would give me some visibility into the network. It's just, I always question, am I seeing everything? And I know with a tap, I am seeing everything. and I'm seeing it in the order it's going across. So that is where I want to get, right? I want to get to that pristine visibility where I'm seeing all of the packets. I'm seeing them with the right timing. I'm not dependent on knowing the commands of every one of my switches to set up that span. But sometimes we can't always get those taps in. So I would say that, for me, if I could get some aggregation in there and start pulling those data sources together that I have, and then start working through those and updating those, that would be an approach if you had to do it incrementally.
So to tie it a little bit back to kind of the physical hardware that you would use, a first step could be to say, okay, let's start using span ports at critical points, but having one aggregation tab where we then combine those ports together and have a single point of connecting our further analysis tools or getting the information out of the network. So we don't need to redesign, reapproach, reintegrate the whole solution at one point, but we can gradually introduce more visibility to it, with the caveat being that we know that we're not going to see 100, or we cannot be certain that we are seeing 100% of the traffic.
Yes.
Yeah.
Yep. Well, and the other thing that aggregation does for us is it gives us that deduplication of packets. And I don't think this is something anyone appreciates until you've worked in an environment where you're capturing from multiple locations and you are capturing the same packet more than once. And even if it's on different VLANs, because a lot of the analysis tools will look above the, that physical or the data link layer where we have our VLAN tagging, and they'll say, oh, I see that same TCP sequence number, same IP identification number. This is the same packet. And now our trace is filled with duplicate packets. And so that is something else that aggregation gives us, is not only that ability to pull those multiple sources together, but that ability to eliminate the duplicate packets so that we get a cleaner trace. And that's, like we talked about, clearing out the things that we don't need to see. And I don't need to see those duplicate packets always. Sometimes I do. I want to see what the delta is between those. I want to see how long it took a packet to get from one point into the network to another. But there's a lot of times I don't want to see those duplicate packets.
Now, when you go, this is obviously starting off. We start off with a smaller setup here. We have this nice confined situation. We all know those kind of offices. The network infrastructure is usually in the broom cabinet, right behind the cleaning material and stuff like that. So it's also a space issue at a certain point where to put additional stuff in it. But when this company, let's say, moves offices and grows bigger, what would you say in the transition phase? We've all seen it. We have a small company. You have usually, software developer sidetracks as an IT guy, or the secretary issues the email addresses and stuff like that. Suddenly you're expanding like crazy. What are your telltale signs that you say, okay, I see where the office has left the same track of network visibility? What are the telltale signs to say, hey, this is an issue you desperately need to take a look at?
Well, I think one of the biggest ones is the second you talk about redundancy, right? If I've got a network where, you and I in our offices, at least in mine, I've got a single connection to my ISP. I've got one router. I don't have hot standby routers and so on. But as soon as we start transitioning from a very simple network into a network where a packet could take multiple paths to get to the same place, that is where we really need to start taking a look at tapping and aggregation. Because now I may have a situation where my packets are coming in on one router and going out on another. And I can't tell you how many times I've looked at traces where I'm only seeing half the traffic. Somebody sends me a packet trace and says, hey, can you tell me what's going on here? I say, no, because I'm only seeing half the picture. And we need to be able to have visibility into any path that packet could take, and then be able to pull that together so that we can then create a complete picture of that communication between the device that we're interested in and the server or host that it's talking to make sure that we can get in there and analyze those problems.
So taking a look at this picture of the bigger infrastructure, starting from the small one, coming to the big one, my assumption would now be to say, okay, we have the same points of attack that we have for the smaller setup. So we want to monitor the firewall ingress and outgress. We want to monitor the server side of things. We want to monitor the wireless side of things so that we can ensure that everything that comes from there and is also captured and monitored. The thing now is that we need to add more physical stuff to it, right? Then instead just rely on the good old span port technology. Now we're talking about putting real infrastructure.
Yep, starting to put in taps, which, as we talked about a little bit when we were talking about the tap presentation, was when you're redoing that infrastructure is the time to do that. That's the time to allocate that space in the rack for that tap. So now you've got your links coming in from your switches. It's nothing to run that through a tap and then bring that into the switch. So now that you've got that monitor point. So, there could be cases where maybe you don't even have all those taps connected to an aggregation device yet, but they're there and you don't have to take down the network to start using them. Now, I will say, because I do spend a lot of time these days teaching people how to certify copper and fiber networks, that when we go to put these taps in, especially on fiber, we need to keep in mind that is stealing some of the light. So when we're putting that new infrastructure in, we need to take that into account. We need to factor that into our loss budget so that we are making sure that when we put that tap in, that's not going to reduce the amount of light that makes it to the far end to a point where there's going to be an issue.
Okay, so what that would mean the taps also need to be considered beyond just adding the hardware. We need to consider the physique of the original network as well.
Yes,
we are back at the more you plan it at the beginning and to start with, the better off you are, right?
Yes, absolutely. And that's something that, if you have that small network and there is any discussion of moving to a larger network, you need to have advanced network visibility stuck up on a board somewhere so that you're always thinking about that. How am I going to add that to my network? Because it is so much easier to add as we make this transition from that simple network to this not as simple network, this larger network, than it is to have that as an afterthought, that now that we grew this network, maybe we should add some visibility to it.
I mean, it's a little bit like in the old days when you bought an 8-port switch and you needed 6 ports. You didn't buy an 8-port switch. You bought a 12 or a 16-port switch because you said, well, I can expand in the future. I don't need to expand right now. Same goes when you bought a 16 one, you bought a 24 one instead and stuff like that. So it's pretty much your insurance policy, right, for the future, that you might not need the visibility right now, but there will come a point where you need it. And for that, you just put it in as an additional hardware. What would you say? I mean, let's be interesting here for a second. Do you have any war stories where you say, okay, how can a transition go wrong? What was or particularly right? What is a story that comes to mind where you say this is where really things got tricky and I learned from it?
Well, I mean, there was one a number of years ago where the IT manager was not going to be able to be there at this big transition that was occurring to the new network. And so they hired me to come in and oversee the transition that was occurring in the middle of the night. And it had taken 6 months to get that outage. And so my task was, whatever happens, do not let this fail. So we got to the point, I was sitting around most of the time, but got to the point where they went to turn the network up and it wouldn't come up. And, one of the things that they hadn't implemented, because they were trying to keep their budget as low as possible, was a good way to go in and monitor the traffic. And when, we had a very short window to try and identify why this network wasn't coming up. And we went through and eventually we found it, but it was much more difficult because of the lack of visibility to figure out why this network wasn't coming up. Now, in the end, it was so simple that I told the guy that if I was wrong, he could punch me in the face, because what I was going to tell him was so rudimentary. But I said, did you do a no shutdown on this one main port? And he goes, oh. And so, but by looking at the traffic, we were able to see that we weren't getting traffic from there. So we did the no shutdown, everything came up. And when we're doing a big cutover like that, it's easy to make a mistake like that. And in the end, I didn't get punched in the face. But it's one of those things where it typically comes from a lack of visibility. I got to say, in those cases where we've had customers that have gone in and put that effort into putting that monitoring infrastructure in, we are able to transport ourselves. In fact, I heard an interesting one, and that is on Star Trek. One of the reasons that they did the transporter was because it saved the cost of having to have them land on all these different planets. So by transporting them down, they just, boom, were there. They didn't have to have this shot of a ship landing on the planet and so on. So why I say that is with that network, with the taps, and being able to have ways that we can set up filters and point ourselves very easily at a specific tap, we can transport ourselves to that point in the network just like that, and we can do it remotely. And that's another big part is, if my monitoring solution depends on the fact that I move my analyzer from one point to another manually, then that means that I have to come in and do that. And I've seen people where they have gone in and set up the taps, and they're moving their analyzer from one tap to the next. But being able to do all of that from anywhere in the world means that I can be sitting there, I can have my IOTA attached to my aggregation device. My aggregation device is attached to my taps. Now I can transport myself to any point in the network and see what's happening right there without ever touching a cable.
You're raising an interesting side question for me. Would you say that when you consider going from a smaller network to a bigger network, it would be prudent to first integrate taps and take a real picture of the network we are seeing? Because what we often do when we look at historically grown systems, we assume a modus of operandi. We assume how it will work. We hardly ever know how they do it. We assume it because we configured it as such, and because we assume that we did everything correct, it all works like we want it to be. But we never really, until you see it, you never really have proven that it actually works, right? So would you say that one of the steps when you go from a smaller size to a bigger size would be first to really have a full visibility of the current system so that you can then more easily foresee issues with the transition?
Yes, and to put a system in that's dynamic. I mean, we need to be able to adjust our monitoring system without, ideally, we want to adjust our monitoring system without having to recable or reconfigure things. Because as the people doing the monitoring, it's always our goal not to take the network down, not to cause any problems, not to do any harm. So by putting in taps and so on ahead of time and getting those in the best places we can foresee getting them, then we can then start taking that data that comes out and start massaging that as the needs of the company change, as those applications change. We've seen such a move from internal applications to cloud-based applications. And so a lot of our monitoring has turned from being able to monitor those internal servers to being able to monitor those internet connections and see what's happening there.
All right, let's shift gears to really complex enterprise level situations. Do you have a war story about what was one of the most intricate aggregation deployments that you've ever worked on?
Well, I mean that would be a case where we'd heavily tapped all of the connections going out to the switches, going out to the key routers, and so on, and then brought that into aggregation devices, but then taken those aggregation devices and taken some of the outputs from those and aggregated those as well. And what happened is, as the size of the organization grows, we start seeing that, as you mentioned at the beginning of our talk, I've got a few friends that started out as admin assistants and became network administrators because the server was under their desk. And, and now we've seen where we've moved from that with a real simple environment to where we have teams of people that are responsible for voice, for security, for various applications. And what we find is that from a security standpoint, we don't want everybody to have access to all of the data. So we may end up taking, and like in these more complex situations, adding in aggregators and handing out data to each of these groups and just giving them that traffic that they not only need to see, but are allowed to see. So I remember the first time that I captured a voice over IP conversation at a customer during a class, and we showed them it could be played back. And they went running out, one of their folks went running out of the room, came running back in, waving their hands, going, we can't do that. And so we showed them how to slice so we could take the audio off of there. But security then becomes a huge concern. And so in the more complex environments, what we see is that we start taking and aggregating the aggregation. We start applying filters so that we can then go in and hand each group exactly that traffic they need, no more, no less.
I mean, one of the things that comes into mind, obviously, in those kind of scenarios is costs, right? How would you approach balancing coverage with costs?
Well, the first thing is getting in line, right? Until we get the data, none of it matters. But we see that, like from Profitap has the booster, which I still think is one of the neatest from a small organization standpoint, is one of the such a cool tool because it allows me to take and put 4 ports I can tap in line, and I can aggregate that into a single port. So from a very small cost-effective standpoint, now I can come in and I can start tapping in and aggregating some of my traffic. And I can put a couple of those in. So now I've got up to 8 points that I'm aggregating together. So from a very small standpoint, I could start with something where I'm just aggregating a few links and bringing those together. And as you mentioned, we don't want to buy a device that is only going to fit our needs today. And so once we start moving beyond that, it's taking a look at what investment can I make into my network monitoring infrastructure. We saw with the big outage that occurred recently, the cost of being down, not only for the company, but for any of the customers that are affected. So being able to minimize that downtime is worth something. It's worth a lot.
We've covered a lot of stuff. Looking forward, what would you say is one of the biggest trends shaping the future of network aggregation?
Well, certainly being able to handle higher speeds. Number one, being able to come in and take our 40, 100, 400 gig links and start being able to pull traffic out of there. And doing that, being able to handle the filtering and aggregation at those speeds is a really big one, because now we're looking at more data. Speed is cheap, storage is cheap, processing is cheap. So I've got one customer here in the Seattle area that they're getting ready to put in a 400 gig link, and they're putting 25 gig links into the desktops for moving data. So I would say that one of the trends that we're seeing is not only being able to get the visibility, but being able to handle that visibility at a very high rate, and then being able to, apply filters and rules to that will get us the data out of those higher speed links and get it to our analysis equipment.
Well, this has been, and again, quite an interesting and extensive discussion, as always. To wrap things up, if you could give one piece of advice to someone looking to improve the network visibility, regardless of the size, what would it be?
I would say make sure that your network monitoring infrastructure is separate from your network infrastructure, so that you can change your network infrastructure without changing your network monitoring. And if nothing else, get something, start somewhere, and get in there and start building that. I've just always thought of so many networks are like if we built a car and then welded the hood shut, because nothing's ever going to go wrong. There was a line of, I think it was the Ford Mustang, where the spark plugs were so close to the firewall that you pretty much had to pull the engine to change the spark plugs. And so there was a case where somebody built the car to try and make the cars efficient, compact, whatever they were targeting, but they sure didn't target maintenance. And at some point, your network will have a problem. And somebody will come to you if you're in charge of fixing it. They're going to want you to fix it. They're going to want you to fix it now. In fact, they want you to know what happened already. And we will, and I'm sure in more of these talks, we'll talk about back in time. But that is where not only do we need to be able to have that visibility into the traffic today, but we need to see what happened yesterday at 3 o'clock when everything slowed down.
Well, thank you so much, Mike, for today's episode. This has been incredibly insightful. Thank you all for listening in, and see you at the next one. Take care, everyone.